Hi, good afternoon, everyone. Can you hear me? Okay, I'm clearly audible, right? Sure. I'll share the PPT and then we'll get started. Yeah, just tell me if you are able to see the PPT. Is that clear? Okay, let's start with that. I'll just do the full slide. Right? Okay, let's begin. Let's look at these questions. Okay, let's start. Okay, so what's the answer you get for the first one? So let's say if it doesn't matter what are the answer options he marks, right? You're not interested in the answers that he is marking, right? Then what are the number of questions he could attempt? In the first case, we can simply say that out of 4 questions, he can attempt all the 4. The order in which he solves the question doesn't matter, it's 4C4, which would be 1. Whereas if you look at the second question, it can have any number of questions. So he can attempt no questions, which is 4C0, or attempt 1, that's 4C1, or he can choose to attempt 2 or 3 or all the 4 questions. Correct? So in that way, if he solves none, that's one way. 4C1 would be 4. 4C2 would be, now remember some shortcuts. NC0 is always 1. So is your NCN. NC1 is N. NC2 is equal to N into N minus 1, the whole divided by 2. And similarly, NC3, you can say that would be equal to N into N minus 1 into N minus 2, the whole divided by 6. Right, so these are certain shortcuts which you can use. So 4C2 would be 4 3s are 12 ka half, 6. 4C3 is same as 4C1, right? Because 1 left and 3 attempts is same as 3 attempts and 1 left. The possibilities remains the same, you know. If you select 1, you reject 3. And if you, which is same as, 4C1 and 4C3. So 4C3 will also be 4. That's the reason why you see the NCRs are symmetric and 4C4 is same as 4C3, which is 1. Which you add 14641 adds to exactly 60. Now a direct shortcut to this is, if you know, this would be same as 2 raised to 4. So you can remember this relation that NC0 plus NC1 plus NC2 and so on till NCN. This whole adds to 2 raised to n. Right? It's 2 raised to n, which is 60. That's right. So these all goes on and it's equal to 2 raised to n. So this is a shortcut that you can use. Okay, guys, just let me know if you're following it up. If there's any doubt, please ask me. And in the case there's at least one, so we don't want this part. So just take it on the right side. So which is minus 1. And then the answer would be 50. So at least one thing is 2 raised to n minus 1, for which you can use the same relationship. And then take all these cases that we have. Yeah, are you guys clear with the role of NCR when you to use NC0? See, as far as GRE is concerned, they will not go anything beyond this, right? It's a very simple, fixed set of rules, right? So the firstly, if you look at the basic theory, okay, that's the two fundamental principle of counting. So the FPC is what we name them as, you know, the fundamental principle of counting, which would cover everything related to that. So if we need to check on that, so the fundamental principle counting states that the OR rule and the AND rule, right? So let's say if a person has to travel from Mumbai to Delhi, right? There are 5 flights, there are 4 trains. So what is the number of ways in which he can travel? So number of ways in which he can travel from X to Y. So what would be the answer here? What are you going to do with 5 and 4? Would you add or would you multiply? You multiply 5 into 4. You say 5 into 4, which is 20, or you would say 5 plus 4, that is 9. You should multiply or add, right? Because he would be deciding, firstly, whether he wants to travel by a flight or by a train. So his choice is going to be either a flight or a train. He cannot travel in both of it at the same time, right? So if he decides he'll take a flight, which means he also ends up rejecting the option of train. And if he travels by train, that implies that he rejects the idea of traveling by a flight. So it's only one case that you have. If it's flight, there are 5 ways. If it's train, there are 4 options. So in all, he'll have total of 9. There are 9, you know, mode of travels possible for him. He has to pick one of it, and that's why the answer would be 9, right? Whereas if the question is, right, if the question is, okay, now let's say he has to travel from Mumbai to Delhi and then Delhi to Bangalore. There are 5 flights between Mumbai to Delhi and then 4 flights between Delhi to Bangalore. Now, how many ways he would travel? Okay, so in this case, it's a case of and. He has to travel first from Mumbai to Delhi and then continue from Delhi to Bangalore. Right. So with 5 options here, let's say A, B, C, D, E. These are the 5 flights, and have 4, right? X, Y, Z, W. Then with A he can take X, with A he can take Y, or with Z, or with W. So with first flight A he can pair it with any of the 4. Similarly, second he can pair with any of the 4. He can pair the third with any 4. So is true with fourth or with fifth. So here you are generating cases. So for each option in the first, he has 5 options. And similarly, he has 4 options out here, right? So therefore, he will end up making 20 choices, right? So the rule is, and this is what basically, the GRE questions would try to test you on. If it is, if there's a job, X that you can do in M ways, and there's another job Y which you can do in N ways, then the number of ways in which you can do X or Y, that is M plus N. And then if you have to do X first and after that Y, then it is M into N, right? So these are the 2 cases that you need to deal with. Is that clear? Right? So this is the basic fundamental thing. And then the knowledge of NCRs, which is n factorial over r factorial, n minus r factorial. Whenever you use this, the order is not important, right? And then the NPR, which is n factorial over n minus r factorial. Here, order is important. As you would see, very few questions would use the notion of NPR and NCR on GRE. They don't get too much into this thing. They don't design questions which are very much based on the NPR and the NCR logic. They want to solve majorly through the basic whole understanding and the fundamental principles. But we can still use NPR, NCR for the sake of simple calculations if it are eased out. So that helps. Now, let's look at this. The first case here attempts all questions. So out of 4, he has to attempt all 4. 4C4, that is 1. So that is done, right? Second, he has to attempt any number of questions, which is, as you saw, could be anything from 4C0, 4C1, 4C2, right? In that case, as we took it, right? And then at least one. So there's not much difference between these two. So if you look at B, he's not decided how many questions he would solve out of 4. So he could, you can say the number of questions he attempts and he leaves. He can attempt all 4 and leave none. He can attempt 3 and leave 1, 2 and 2 left, 1 attempted and 3 left, none attempted and all the 4 left. So these are the possibilities. So the number of possible cases of attempts is 4C0 plus 4C1 plus 4C2 plus 4C3 plus 4C4. Right. Now is the thing, like if you're looking at question 1, how many options he can make? He can either say I'll attempt it or I'll leave it. So every question he has 2 possibilities. And there are 4 questions. You know, Q1, Q2, Q3, Q4. Right. There are 4 questions. Now instead of going this long, on the first he decides whether he attempts or leaves. Second, he decides whether he'll attempt and leave. And the third and the fourth. So he decided what to do with the first and then the second and then the third and then the fourth. So total there would be 2 raised to 4 cases, which is what this would be equal. Right. So if you individually calculate, this turns out to be, as we saw, 1 plus 4 plus 6 plus 4 plus 1. That's add exactly to 16. Right. So hence this would be true. So remember this rule, that helps. That ends, in fact, you can just write out summation, you know, I running from 0 to NCI is 2 raised to n. So take the summation of NC0 plus NC1 plus NC2 plus NC3, so on and so forth, up to n. That is equal to 2 raised to n. Okay, so that will be this. It's a shortcut for that. In case if this one asks you for at least one, in the case of at least one, right? In case of at least one, what we see that the zero wala case is not possible, as he has to attempt at least one. Right? So therefore, subtract that one possibility, and that would be 2 raised to n minus 1, which is in this case 16 minus 1, 15. So that will be 15. Okay. Other basics we just keep covering. The first part will just cover through all the basics only. So as you were saying, let's let me just cover up something on the basics of PNC. The first half of the set questions today we'll cover up on that, and then we go to the type of problems that you see on the real GRE. Okay, the first portion would cover these things to basic set of questions. How do you deal with that? And the second half would be how do you see those questions on GRE and how do you use these concepts? So we are anyway going to cover up all these basics thing, one on one, Abhi, in the first half of it. Is this question clear? Is there any doubt on this? Okay, sure, good. Let's now move on to the next one. Then you have the digit based questions. So 2 cases. Okay. One is repetition allowed, second repetition not allowed. The only possible digits are 2, 5, and 7. So just check. Check. Remember the standard time. Yeah, so answer to the first one, when repetition is allowed. Repetition allowed है तो कितना हो जाएगा? Units, tens, hundreds. You can use any of the 3 and a 3 and a 3. So that's 3 into 3 into 3. That's 3 cube, right? Which is 27. Okay. And when repetition is not allowed, you cannot repeat the digits. So units, tens, hundred. You can use any of the 3 digits. जो भी use हुआ है वो tens पे use नहीं कर सकते. So only 2 options left. And units पे only 1. So 3 into 2 into 1, which is 6. Right? So the first one, 27. And the second one, 6. Perfect. So 21 and 6. Right. Now, just an extension. अगर 0 भी होगा, then what will be the case? If there's 0 also, then what would you do? 192. Wait. Check it. Can you have 0 at the first place? It's a digit, not a code, yeah. So of course, either भी वही दोनों cases का cover करेंगे. Let me just post the questions. Repetition allowed, repetition not allowed. ठीक है? अब यहाँ का repetition allowed है. Let's take this 2 cases, no? Units, tens, 100. अभी 0 not allowed, no? Either. So we have only 3 cases. But इधर 0 use हो सकता है तो इधर भी हो सकता है. Right? 48. When repetition is allowed. Perfect. And when repetition is not allowed, again 0 not allowed. So 3 cases. अब जो भी digit इधर use किया, let's say I used a 2 here. Then second place पे I cannot use a 2. But you can use a 0 then. So again 3 cases. And then 2 cases. And, right? It's only this. Right? So 3 into 3 into 2. Right? So therefore 80. Perfect. That will give you 80. Right? So simple. These are how you go about. So the only trick that you have in this case, the digit-based questions are the 0 wala part. You know, when 0 is involved, you don't have to use it in this case. Now suppose, let me say, right, if just a minute. Can you see it now? Just stop there. Okay, now in this case, if the question was not about 3-digit numbers, it was codes. Then what will be your answer? So here the question was not about 3-digit numbers, but 3-digit codes. You don't have to form a number, but you have to form a code. So can you have 0 as the first digit in a code? Can we have codes starting from 0? We can, right? I mean, the most famous code that you can say is a 007. It's not 7, it's 007, right? James Bond. So it's a 3-digit code, it's not just 7 that you see. So therefore, in that case, it is going to be 4 into 4 into 4, which is 64. And then in the second case, it is going to be 4 into 3 into 2, which is 24. Okay. So codes में 0 का issue नहीं आएगा. It's only in the numbers that you usually have. Now we know in terms of linear arrangement, n things can be arranged in straight line in n places, of course, in n factorial way, right? So if there are n chairs and n students, then you can arrange n students in n chair in n factorial. So if the question is how many ways can 5 boys be arranged in a straight line, what is the answer? It's simply 5 factorial, which is 120. Perfect. Now, but the same thing if you try to do it in a circular way, then you don't have n ways, you have n minus 1 because there is no fixed reference to begin with. Like in the linear cases, the starting point is the left one and the end point is the right one if the arrangement is happening in the left to right mode. Similarly, if the arrangement here on a circular is happening in the clockwise sense, I don't know which point to begin with because a line segment has a starting and an end point, whereas a circle doesn't have a starting or an end point. So any of these 5 could be taken as the first point. So there's no idea or concept of first in the place. So moment, A, let's take the first person goes and sits anywhere because he doesn't have, he's not been instructed to go on which one, two, three, four, five. There's nothing like that. So all the seats are just the same to him. So he goes and sits anywhere. Wherever he sits, now that becomes my reference, and hence I can now start arranging every other person with respect to that person who is my reference. Right. So it's one place away clockwise, two place away clockwise, three clockwise, four clockwise, and like that. So that's why you have loss of one, because that one object is used as a reference. So 5 boys in 5 places, right? It would be 4 factorial, which would be 24. Right. Although circular arrangements are hardly tested on GRE. Okay, try this. Now it's not the arrangement of the people, but of the words, letters in a word. Okay, so check this. Yeah. So what are the number of ways in which you can arrange? As you see, Paris, all five letters, all different. So that is 5 factorial. When all the letters are different, n things, n letters, n places, n factorial. If they start repeating, then you start dividing by that. Like in rigid, if all of them would be different, it would be 5 factorial. But you see, I repeats twice, so I'll divide it by 2 factorial. So although this is 120, this is going to be 120 on 2, which is 60, right? Similarly, if that's peeps, I just see if everything was different, it would be 5 factorial. But E repeats twice, so you divide by 2 factorial. P repeats twice, you divide by 2 factorial. So that is going to be 120 on 4, which is half of 60, which is 30. So you divide by the number of letters that you have, because if you fix everything and just try to interchange the identical letters within itself, it is not going to give you a new word but the same word. So I'll explain you this logic. So let's say in Paris, and there is rigid. Let's consider these two words. Let's say fix, P, R, and S, and try to interchange A with I. The word you get is Piras, which is different from Paris. But let's say I fixed RGD and I interchanged the I's. What you get again is RIGID. It is not generating new word, but it is giving you the same word back. So when you rearrange identical letters within itself, it would always get you the same word again and again. That's why you don't subtract, because you're still getting the same word. So it's only one single output. It's not zero. When you subtract, you actually remove everything. I don't have to. So that's why you divide. So let's say there's a word Mississippi. What would be the number of ways in which you can arrange the letters of the word Mississippi among themselves? Then what would be your answer? Tell this. Write down it only in terms of factorial. You don't need to simplify to a single numerical value. Write the answer in the factorial way. Right? So we see there are total of 12 letters. Sorry, 11. The total of 11 letters. So 11 factorial if all of were different. Out of which I repeat 4 times, so 4 factorial. S repeats 4 times, so 4 factorial. P repeats twice, so 2 factorial. So 11 factorial divided by 4 factorial, 4 factorial, 2 factorial. Okay, perfect. Good. Now try out another variant of this. Okay, check this out. How much are we getting? 24 and 6. No. How come 6 so less? So when things wants to be kept together, you can just arrange them in one group. Like here, the vowels need to come together. So A and AI would be one group, and then P, R, and S. Right. So there are one group together and the other three. So total 4. So that is 4 factorial. But AI can also be rearranged inside as IA. So 4 factorial into 2 factorial. So 24 into 2, 48, which is correct. And if you want the consonants to be together, then it is P into R into S, and with A and I. So that would be 3 factorial into 3 factorial. Right, perfect, which is 36. If I want both consonants and vowels both together, then what would be the answer? All the vowels are together and all the consonants are together. Then, quick. Then what will be the answer? So I'm going to have one group of vowels, AI, and one of the consonants, PR and S. So that's going to be 2 factorial into a 2 factorial into a 3 factorial. This is external, this is internal, right? So 2 factorial into 2 factorial into 3 factorial. That's 2 into 2 into 6. 6 fours are 24. The answer would be 24. Right? So as you keep grouping them, you see the number of arrangement keeps on reducing. First only one group of 2, then group of 3, and then 2 groups of 2 and 3. The number of possibilities reduces, right? That's right. This is simple. This is actually the answer of the 2 previous questions. When you don't want all of them to be together, all the vowels don't come together, then we take a complement way, which is faster, instead of splitting them into cases, right? Which will have multiple cases possible. So when they are together, it's 5 factorial, total. Out of that, in the together case, we have, you know, 2 together. So that was 4 factorial, 2 factorial. So vowels don't come together. That's 5 factorial minus 4 factorial. And consonants, again, 5 factorial minus this was 3 factorial and a 3 factorial. Right. So this is just a complement way of when all of these don't want to be together, right? So that taking complement way is much easier and faster in that case. Now we'll have questions which would be like what you're going to see in the test, right? That was just a quick run through the basic that is relevant to GRE, and that's all what you would be tested on. Now we'll move on to the questions which are more like GRE. Okay, start. Try this. What is the answer? 1, 1, right. Samyuk, how did you get 4? So, if we consider, say, a circle, right, with 7 points on it, randomly anywhere, 1, 2, 3, 4, 5, 6, 7. Now, in order to draw a triangle, I would need any 3. So, 1, connect this, I connect this to this, and this to this. So, there's going to be 4C3. In order to draw a quadrilateral, I would choose any 4 points at random, could be sharing with the triangles. But let's say triangles are gone now, it doesn't matter. So that's going to be 4, not 4C3, sorry, 7C3 and 7C4. So there's 7 points. So 7. Right. So it's 7C3 for triangles and 7C4 for quadrilaterals. Now, NCR same as NC n minus R. So 7C3 is same as 7C4. So that's gonna be 1. They're gonna get cancelled out, right? So hence the ratio will be 1. Right? Perfect. I would just, can you just post, okay, why did you end up marking 4? That's the number of triangles be 4 times that of the quadrilateral. That would not be the case, right? So this is fine. This one is easy, same concept of grouping together, right? So let's go through this quickly. This is how you would see a question on a GRE, which will use the idea of, things being grouped together, something like that. Okay, try. 4 factorial into 4 factorial into 3 into 3. 6, 9, 1, 2. Yeah. So we want all 4 botany together. So, sorry, have these 4 botanies together. 4 botanies. Then you have 3 different sociologies. So have 3 sociologies together. 2 physics. So 2 physics and then 1 bio. That's separate. Anyway, keep it separate. So I can see there are 2. There are 4 of the groups, which can arrange then among itself in 4 factorial. And then internally, botany is in 4, sociology is in, I'm sorry, 3 factorial, not x factorial. Not bad. That's 2 factorial, and this is 1. So 4 factorial into 4 factorial into 3 factorial into 2 factorial. Yeah, that's going to be the right. 6912 would be the product. Perfect. Good. Good. Now check this. This is a very typical questions on the walks, and there's a good shortcut to it. So let's try this out first. Yeah, what's the answer? Okay, still trying. Do that. Check, check, check. Yeah, let others also. Why only one answer till now? Is there difficulty in this? In understanding that?
I see the answer coming only from Aditya.
Okay, so when we have to look at what is the minimum possible length that a person can take, well, actually, we need to just see how many units he can move. So the moment we can define in terms of left, right, and up and down, right? So in this case, it's only going to be the right sides. So he has to move right twice, the right and the right, and three times up. So up three times. So the shortest path would comprise of two right moments and three up moments. Now this could come like a first up here, another up, and then he takes a right, and then goes up, and then again a right. Could be distributed anywhere. Or he could have gone three ups and then two rights. Or he could have started with a right and then up, up, and then right, and then up again. So all these comprise of shortest possible routes. He can go like this, he can go like this, he can go like this, all of this. So how many are possible that you need to set and work out? That would be too lengthy. So what you can say here is, and how do you know this is the shortest possible route? What would be a longer one? So the longer one could be, he goes 1, 2, 3, 4, and then he goes in 5, 6, and then 7. So this would be one of the possible route that he can also take. But this is not the shorter one. That's in fact longer because he's looping himself, right? So in fact, if the question, I'll come back to that question. Let me not answer that. I'll come to that question. So the shortest would comprise of two rights and three up. It's like there's a word comprising of two R's and three U's. How many arrangements are possible? I would say that's 5 factorial on 2 factorial, 3 factorial, which if you see is same as 5C3, also 5C2, right? So 5C3 and 5C2. So total, there are 5 moments. You can say R plus U, out of which how many R's can you select, which is same as R plus U, C, U. Mostly the questions would be right and up. That's generally a lower point to a higher point. So that's usually the one. You can also say the horizontal plus vertical and plus the horizontal. You can comprise these as the horizontal moves and these are the vertical ones. Whichever one is convenient, however you want to see this, right? So the answer would be simply 5C3 or 5C2. If you just move up, yeah, that's what. You just keep moving up. I'll make you reach here. But from there, if you need to move to Y, you have to take two rights, right? So you see how many columns away it is. It's two columns away, right? So you need to shift by two columns, right? No, you have to travel only along these grids. So I have to shift two columns to the right and three rows upwards from the existing point. So the given point is two columns right and three rows up. So you can just look at this in terms of rows and columns also. That's the number of shifts you need to have to reach to that grid point. So I have to shift two columns. From this column, this is my, default one. No, no, that's an invalid assumption. So then how would you travel? See, that would change the question. No, then it's not. Then it's a totally different question, right? Then it's a totally different question if that is the missing part. If you have modified that. So let's say if one of this path is not there, okay, say for example, as you're saying, let's say this path is blocked, is under repair, correct? Then what I would say is he has to first of all reach to this point, okay? So all the paths which he can take are this column and this column. I would forget about this column. So for this column, he would be open for all the possible paths, any possible paths through this will not create a problem. So instead of taking three, you know I would say only these two possibilities, right? So he can shift from this point upish or this point upish, but not this one. So this route won't be considered, and then we'll evaluate this route separately. So what he needs to do is he would not travel to this 4th street in this path on avenue A. He would take a diversion right from the 3rd street, and then he can travel. So which will still be 1, 2, 3, 4, 5. The shortest path won't change, but it will just delete some cases. So you could say all cases minus the number of cases that was passing through this route. Subtract those and you will get the answer. So you will use a complement method. Is that clear? Correct. Then I will not take. So ये चला गया, ठीक है, ये block there. Total we have 10. Out of that, how many routes that were passing through this point, because he cannot travel through this. So we won't take this one. We'll subtract. He can still go 2 U's, then a right, and then a U, and then a right. So subtract all those cases that would be passing through that road. Leftovers is your answer. Okay. So that would be a shortcut for this one. Now suppose, let's take another case. Uh, there is this point C. So let's say he has to drop his girlfriend, which stays at Z. Point Z. So he starts from Y, so the point X, right? He stays at Y and his girlfriend's at Z. So he would first drive to Z, drop off his girlfriend, and then move on to his place at Y. Then how many possible shortest route he could take? Okay, where he has to travel definitely through Z. Every route should pass through Z, not L. So one way you can look at is, since he has to definitely pass through Z, I'll find the shortest route from X to Z and then from Z to Y. So X to Z, 1, 2, 3. Correct? So 3, you have to say 3. C, 1 into, from Z, it's 2, 2C1, which is 3 into 2, that will be 6. So in how many shortest way he can travel from, X to Z, where he has 3 units to travel, out of which one is, row, 2 rows and 1 column. So 3C1 or 3C2. Similarly, Z to Y, 1 row, 1 column, so 2C1, which would be
3 into 2, that would be 6. Okay, so you can break it into that. Or total minus all the roots that will not be passing through Z, but that would be difficult because then you'll have to list out. So this would be a better way of looking at it. Okay, check this. Good question. It's a little long, but it's a good one. Check. Okay, so what is the answer? B, right? 5? Yes. So what we can see is simply if it is 4, then one color selection 4C1, and when you select 2, order doesn't matter, that's why we're using C. So 4C1 is 4, 4C2 would be 6. That will add to 12, which is less than 10, sorry, which is less than 12. So 4 is out. If it is 5, you can say, right, it's 5C1. So that's 5C1 plus 5C2. 5C1 is 5 plus 5C2 is 10, which is 15. greater than 12. So will work. Right? So hence the answer 5 will work, definitely. Check this. Yes, you can ask a question. I'll go back to that. Akshat, it won't be possible with 4 na. 12 चाहिए ना, and the order of the color doesn't matter. So if you are keeping a box, let's say you color red, green, this and this, green, red, this the same. They're not distinct. Yes, given in the bracket, assume that the order of the color in the pair does not matter. If the order would have mattered, then yes. It's just that यार ये box है, let's say Amazon के boxes, cartons, red green है, तो carton को upside down रख सकते हैं, right? You can keep it anywhere, no? So it doesn't matter. It should belong to the same, no? Okay, I'll show you. Let's see here. If you have to write, say I'll use 4 colors. Okay, we are using the 4 colors: red, blue, green, and let's say yellow. Okay, so when you use only one color, R, G, B, Y, total 4. When you're using 2, R, B, R, G, R, Y, B, G, B, Y, G, Y, which is 6, right? So therefore, these are the 10 outcomes that you'll have, right? Now, if I add one more to this, okay, let's say you use a violet. No, if I have 5 violet, so I'll have one more added here. That will be 5. And I can have violet red, violet blue, violet green, violet yellow, and have another 4 here, which will make it 10. So you're gonna have 5 plus 10, which is 15. Okay, and that's how you get that 15 there. Right, so 5 is good enough. 4 won't be sufficient. Okay, now check this. What is that? 152, 144. Option A, 144. Okay. Uh, making a silly mistake. The A ones. Let's see. 3 cases, units, tens, hundreds. This has to be, there cannot be 0 and 1. So ye out. This has to be only 0 and 1, right? And these two cannot be both 0, 0, right? So let me say first, forget about the third condition. Okay, you cannot have a 0 and 0 in both, right? Then how many outcomes or possibilities would you have? So I'll have 8 cases in the first one. So there are 8 possibilities. There are only 2 possibilities here, and then I can have anything here. Let's say 10, right? So therefore I'll have 8 into 2, 16 into 10, 160 cases, where I also included the possibility of the last two being 0 each, right? Now I'll just subtract this out. So how many numbers are there which are going to end with a 0, 0 that are not allowed? You can have any digit here from 1 to 8. So 8, which is 8. So 160 minus 8, which is 152. That's why B is allowed. So all of you who marked 144, you actually ended up also removing cases with a 1, 0. 1, 0 is allowed, yeah. Only 0, 0 is not allowed, right? So that's why you need to subtract only 0, 0 cases. Oh, is it? So that's, oh, 152 is the right answer. Or you could split it into 2 cases, right? This was the complement way. The other direct way would be when it's ending with 0. You can have 1 to 9, actually. No, sorry, 2 to 9. So 0 and 8 is 0 and 1 is not allowed here. So you can have anything from 2 to 9. 8 cases, it's 0, 1. You cannot have 0, but 1 to 9. So that's 9. 8 into 9, 72. Second case, when it's 1, you can have again 2 to 9, 0, 1 not allowed. 8 possibility, 1, and you can have anything from 0 to 9, 10, which is 80. So 80 and 72, which is 152. You get like this as well, right? Okay. Now check this. That's good. Let's see who gets this. What is the answer here? See, uh, this problem can simply be solved by merely, thinking from the idea of symmetry. So let's say if there are three people, ABC, standing in a line, so there would be six possible, right? And CB. Now I'll say in how many cases there are where A is before C. So fix B here as the last. The other person is, or all the other people, forget about that. The relation is between C and A. So when B is at the end, you see there are exactly two cases, right? Because A and C का बात कर रहे हैं, बाकी सबको उधर ही I'm sorry, बाकी सबको उधर ही fix कर दिया, right? So everyone is sticking to their places. Only A and C goes and swaps. So I have one case where A is ahead of C. The other case when C is ahead of A. मेरे को इसमें interest है, इसमें नहीं है. Similarly, when B is in the middle, okay, then I'll have two cases when B is in the middle. Again, C ahead of A ahead of C. So इसमें interest इसमें नहीं. Third case when B is in the first place. Again, A is ahead of C, A is behind C. So I'll say for every case where all the other people are fixed, you will have exactly two possibilities. A is either ahead of C or C is ahead of A, which means every possibilities would have only two outcomes. And if I count, it will just add up to the total number of cases. So the number of cases in which one person is ahead of the other is simply n factorial by 2. So if I ask what's the number of ways in which A is ahead of C, it's n factorial by 2. And the number of ways in when C is ahead of A, it's n factorial. A is ahead of Z, Z is ahead of B, whichever. You can just think of fixing everyone at their places and then these two swapping up, and thus would generate all the possible cases through symmetry. Now in this case, there are four people, so the answer would simply be 4 factorial on 2, which is 12. So it would be exactly 12 such cases. Right? So remember this as a shortcut. For this question, the answer is always n factorial half, n factorial by 2. Okay, by symmetry simply. Okay, so this is the last question for today, based on counting. How many different ways can four different ball be, you know, put in three different boxes? If any box can have any number of balls, this is slightly tricky. Okay, see how you handle it. Yeah. What's the answer? 81, 12, 15, 51. Okay. Now here, the question is not about arranging, you know, three, four balls in three boxes, or selecting, four balls from three boxes. It's about distributing. So you can say it says ball one, two, three, and four, and the boxes A, B, and C. Right? Then we have to distribute first in any of the boxes, so it has three possibilities. One, two, three. So three ways. Once one is done in whichever box it goes, then you pick the second. Second can go in either first or B or C. That also has three ways. One and two done. Now third again can be in any of this. So into three. Let's say third is here, and fourth can also be in any one of the boxes. So that's another four. So that's 3 raised to 4, which is 80, right? You can simply say if there are n different things to be distributed in r different boxes or groups, then the number of ways to be done is r to the power n, right? So 3 to the power 4. That will be the answer. Okay, is that clear? So you can just write this directly as one shortcut for all these type of questions. So n different things, it has to be different, huh? To be divided into these different boxes. So here, in this case, n is 4, 4 balls, 3 boxes. So hence what you get is 3 raised to 4, which is r to the power n. So that's a shortcut to this type. Should give you the answer. Is that clear? Right. Okay, so this is the last type of question. It was a tough one, of course. It's a hard category one, which we covered in this. In the next session, we're going to continue with the second part of it, which is probability. Right, so we'll see how the probability questions, uh, any of the PNC question can be actually transformed into probability, and what is the approach to take to these type of questions, right? So I'll see you next again on coming Sunday, same time from 3 to 5, on the continuation of the second part of it, which is probability. Okay, till then, take care, study well, stay safe. The, the, the cases are again rising up, and as requested by a lot of you about the extra material, so I'm just trying to make a drive uh, where I'll have all this material, and I'll share the link with you so that you can have an access to all of them instead of just mailing it, again and again to all of you. And just make one drive where I'll upload that and share that with you. Do that in a day or two. Right? Till then, take care, study well. Bye. Thank you.